In this video, we're going to introduce radian measure. In most applications of trigonometry, angles are measured in degrees. And that's because in real life application, what we're going to really do to measure an angle is to use degrees. We're going to use a protractor, we're going to use a computer, we're going to use something to measure in degrees because our brain, processes that well. Well, in more advanced works in math, radian measure of angles is preferred. The reason it's preferred in this more advanced math is because radian measure allows us to treat the trigonometric functions as functions with domains of real numbers rather than angles. So let's consider a circle centered at the origin with a radius of r and an angle theta in standard position. A central angle is an angle in which the vertex of the angle is in the center of the circle. So if we look at this diagram here, theta is a central angle because its vertex is right on the center of our circle. Notice that angle theta kind of cuts part of the circle. Right, if we thought of the circle as a pie, this is the crust of the pie, so it kind of cuts this part of the crust. Well, that crust, is called the arc of a circle. An arc of a circle is the set of points on the circle that lie in the interior of a particular central angle. So again, this right here is going to be our arc. It's on the circle, the interior part of our central angle. Well, 1 radian is the measure of a central angle which creates or intercepts an arc whose length is equal to the length of the radius of the circle. So, however big we have to make that angle so that this arc is the exact same length as this radius, which would also be this radius, right, is exactly 1 radian. Note the radian measure of an angle is unit-free. It follows that an angle of measure 2 radian is going to intercept an arc whose length is equal to twice the length of the radius of the circle. And an angle of measure half a radian intercepts an arc whose length is equal to half the length of the radius of the circle, and so on. In general, if theta is a central angle of a circle of radius r and theta intercepts an arc of length s, then the radian of measure theta is s divided by r.